Hey there viewers, it's Mixy91 and back for more hacking tutorials for Game Boy and Game Boy Color. And just like before, I'm using Pokemon Silver as an example ROM for demonstrating how to do certain kind of stuff. And before watching this part, uh, you must be familiar with all the stuff I've described in part 1 before. So basically you should know how to use a hex editor, search for data, know what an offset is, and that kind of stuff. And basically for starting out, I've decided to show you a little bit of evolution and moveset data hacking. And we're going to do some experiments with star meter. And also before that I'm going to actually tell you how this data works. But before starting out with anything else, I've downloaded another program called Translhexion, and with this one opened, you should be able to follow the hex code much easier than before, because the last time I was using Goldfinger and I apparently cannot make the font or bytes so larger than before. So we're going to stick with this one for now. And I'm not actually quite sure how to work with Translhexion yet, but I do know most of its functions anyway. So we should be good to go. But yeah, let's see what's Marcus is quoting here to here. Could someone provide me with a diagram of Bulbasaur's evolution data in Crystal? And here we can see that in this offset, well, this evolution data is well, it's written in there. So let's just go to that offset. And we should see 01, 10, 02 and 00 here, but apparently we don't. And well, this is because we are hacking Pokemon Silver, and that means that well, the data doesn't have to be stored in a similar way with Crystal, or at least not in similar positions. So because this is the offset for Crystal, it doesn't mean you can find anything related to it there in Pokemon Silver. But I should be able to search for the data though instead. So I'm not actually quite sure if this will work, but what I wanted to do would be searching for those 4 bytes. And coming up with an offset for them. And here you can see that in 429 B3 we have those 4 bytes written in that order. And if we try searching again, we get another offset. And again, another offset, and so on. Well, I'm trying to get back to that offset. Yeah, here. So it happens to be so that this offset here is actually where Bulbasaur's evolution data is located in Pokemon Silver. And by all this information I've told this far, well, you can no way assume it is this one, but it is, and that is because this 00 here, which stands for no more evolutions for this Pokemon, is used to start another data, and which is the moveset learning data for Bulbasaur. And it works so that we have a level in which a certain move is learned, and the move is right here. And we have a second level, the described move, third level, another move, fourth, fifth, sixth, seventh, eighth, ninth, 10th move, and 11th move. And then we have a 00. And this one here tells that Bulbasaur learns no more moves. And this is what Bulbasaur's data is like. And if you remember from the previous part 1, you can use this document GeoGuess Master Hacking Guide for anything, pretty much everything you might need at this point. And here we can see that tackle is 21, growl is 2D, and well, here we got Bulbasaur learns tackle at level 1, and at level 4 it learns growl. 49, that is lead seed, and the list goes on. So for every Pokemon here, we have its evolution data, which ends with 00, and moveset data follows that, and which also ends with 00. And after after Bulbasaur's moveset data ends, we happen to have evolution data for another Pokemon, and you can see straight that this is for Ivysaur, and this is because, well, this 01 here tells that this Pokemon evolves by level, and this is the level it evolves at. Hexadecimal 20 is 32 in decimal, and 03, which stands for Venusaur. And the reason why 03 stands for Venusaur was because we have the Pokemon in the Pokédex order. I don't think it's actually described here. Oh, it is actually. So here, Venusaur is 03. And after this, we have 00 for ending Ivysaur's evolution data, which is followed by its moveset learning data. And you can see that Ivysaur learns 3 moves at level 1, which are those tackle, growl, and lead seed. And it learns growl again at level 4. If it hasn't learned it already, this makes actually no sense, but that's the way it is. Because, well, Bulbasaur learns 2, so it's simply copied there again, this thing. And well, it makes sense for Ivysaur to learn move 16 because it doesn't learn it before that. But these things here are not useful at all because Ivysaur already knows them at that level. And also Ivysaur's data ends with 0, 0, and after it we happen to have Venusaur's data, and its evolution data is simply this 0, 0 here, which stands for it having no more evolutions. And its moveset data follows that and ends right here. And after it we happen to have Charmander's data. Evolves at level 10 or 16 into Charmeleon. No more evolutions. And the list goes on. And then, as you can see, for instance, Eevee works this way. It evolves by stone with Thunderstone in Jolteon, by stone Waterstone in Vaporeon, and so on. And there's also Happiness Case 04, which is followed by 2 bytes for each day situation. I think that if this is either 0, 0, 0, 1, probably 0, 1 is used for morning, day, or night. But 0, 2 is just for morning and day, and 0, 3 for night. And Eevee's evolution data ends here and is followed by its moveset learning data. But anyway, what I wanted to show you about this would be how to work out Pokemon that don't learn any moves from the start. For instance, you probably, if you want to edit, for example, Bulbasaur's evolution line's moves, you can simply rewrite them. That's not a problem. Of course, you still have this small restriction on how many moves it can learn. Like I counted before, Bulbasaur learns 11 moves, so that's what you're going to have to stuck with. But for Pokemon that, for instance, don't learn any moves at all, like Starmie, which happens to be one of these, as I can soon show you. So let's search for 02 for Stone evolution and 18 for Waterstone, because I wanna look for Staryu's evolution data. Staryu evolves by stone, Waterstone into Starmie, and let's check for Starmie's number here, and that is 79. So this should lead into Staryu's data, which happens to be here, because, well, there are no other possibilities of these 3 bytes being written in that order before Staryu's data begins. Or, well, these can be in that order before, but that's that can be possible, but it's not likely. And you can see that this is where Staryu's data actually is, because we have a 0, 0 before it, which is used to end the moveset learn data of Seeking, and here we have Staryu's data. Evolution data ends with 0, 0, and its moves are following it, and in the end it learns move 38 at level 50, I think. Yeah, and that is Hydro Pump. And we have 0, 0 following it, and well, another 0, 0, and this one is for Starmie's evolution data, which says that Starmie won't evolve. And it actually looks like I was wrong about this statement I pulled off, that Starmie wouldn't learn any moves, because it does. As you can see here, we have the moves Starmie learns. But still, we're restricted with 1, 2, 3, 4, and 5 different moves. And that's not much. So, if we wanted to make it so that Starmie would know more moves than these 5, we would have to relocate its evolution moveset learn data elsewhere. And this is what I'm going to talk about next. Okay, I want to take a little pause break again, and simply because the following part I'm going to talk about will be kind of complicated stuff. But don't worry, you should be able to understand it too, if you have been able to keep up with everything I've been talking about till now. Anyway, remember that in the last part, when I opened the script of that fat man in New Town, and it looked like there was that jump text face player command, and those 4 digits after it. And like I said, those 4 digits, they were the ones to determine where the text data used by this guy were looked from. And in this case, we have a similar situation to that one. So instead of there being some kind of code telling the game that these Pokemon datas are stored in order, we instead have bytes determining where to look for these datas. So there is some byte telling that Starmie's data is here, or more properly, telling that Starmie's data starts at this offset. And this offset here is 433 DC. So I was thinking of showing some examples with Notepad, and that way you can keep up better with what's going on. So let's just first write that offset here so that we won't lose it for further usage. And well, yeah, the thing is that the things or those 2 bytes so as I said before, there were those 4 digits after that jump text face player command, and those 4 digits they were 2 bytes actually, and those 2 bytes well, yeah, they determined where the text data was located, and in this case we have 2 bytes telling the game that Starmie's evolution moveset data starts at this offset, just like in that other situation. And those 2 bytes there, they are called a pointer, and pointers work so that they can, because they're bytes, they can have all the values. All bytes can have all values from 00 to FF. So 2 bytes can have all the values from 0000 to FF. Makes sense, yeah. So this is pointer, 2 bytes, or pointer, and here we have 1 byte. Yeah. And these pointers are used to look for data. And in this case, our offset is 433 DC, and we have a pointer looking for that data. And well, pointers mostly point inside ROM data, but they don't have to point inside ROM. And if they point inside ROM, the pointers must be of some value between 0000 and FF7F. And where this comes from, pointer value, this comes from the situation that, like I talked about before, we have these ROM banks, and ROM banks are 4,000 byte long structures. And first ROM bank starts in the beginning of the ROM, second ROM bank at offset 4000, ROM bank after it at 8000, then at C000, then at 10,000, 14,000, and so on. And now we have offset 433 DC. And because ROM banks are 4,000 bytes long, we have one ROM bank starting at this offset, because that's simply 4,000 multiplied by 10. And another ROM bank, the next ROM bank is at 44,000, because that is just 4,000 multiplied by 11. And here we have 433 DC, and that is between these two offsets. And ROM banks are 4,000 bytes long, so the ROM bank that starts here, it ends at 443 FFF. Yeah. If you add 4,000 to this, minus 1, you'll get this address. And this address here is between these two. So it is in ROM bank 10. If you wanted to calculate the ROM bank of any address you got, you put the address in Windows Calculator and divide it by 4,000. And as you can see, we get 10 out of the result. And if you multiply that by 4,000, you get 40,000, which is the start of the ROM bank. And now, to look for the pointer to this data, we first subtract the start of the ROM bank from this. And the start of the ROM bank is 40,000. So we get 3 33 DC. Take this out, and that's the result. And pointers are between these two values. So no, let's not talk about that just yet. But we get this out of it, this calculation. And now you want to do is add 4000 to this. So do this, and you get 77 DC out of it. Next form 2 bytes out of this. It's like, this is not an address, but it's just some result of a calculation you did. And you can form 2 bytes out of it. And now you rotate this around and get DC 77. And this happens to be the pointer leading to this ROM address. So what I did, I checked where this ROM bank starts by dividing it with 4000, and well, let's do that again. So we first divided this with 4000, then do this operation, and you decrease this or subtract this from 433 DC. Get 33 DC, add 4000 to this, and get 73 DC. Yeah. And this 73 DC you use to form 2 bytes, 73 DC, and rotate them around. And as you see, I also made a mistake here, spelling error, but yeah, this is how it should be. So DC 73 leads to this ROM address, and it certainly is between the standards of pointer value. So pointer value can be, the first byte can be anything at all, but the next byte has to be at maximum 7F, and we have 73, and that is okay for us. And normally you actually have pointer values looking like this. So the second byte is normally at least 40. If it's something smaller, that means, well, I'll explain that much later actually, but for now all you have to remember is that pointer has to be somewhere between these two values. As you can see, you form the value with this calculation and add 4000 to this. So if somehow this result was 0, we had 0 here, then we would still add 4000 to it by getting 4000, and you get this out of it, which we have here. So normally you won't get any values smaller than this for a pointer, but they can certainly be. So pointers pointing to ROM data have to be somewhere between these 2 bytes. But normally you get pointers between 0040 and FF07F. So let's make it here look like this too, so we won't get confused. So pointers are between 0040 and FF07F. And here we got DC73 as our pointer, which leads to this ROM address, where StarMist evolution data is located. So our pointer is how to say it? Our pointer is 2 bytes long, and that always means that the pointer is located in the same ROM bank. So the pointer leading to StarMist evolution and moves data is in the same ROM bank. So to look for it, you go to the start of the ROM bank, which is this 0x40000, and search for the pointer, which is DC73. We get an address here, and if you try searching for it again, you can see that, well, you can find it elsewhere, but well, this is not in the same ROM bank anymore, because ROM banks are 4000 bytes long. The ROM bank ends here, and this is much higher address than that. So let's just go back to find previous, and well, now we can see that the pointer to StarMist data is here, and it's at offset 428 AD. So this is what we got here. And now to make StarMist, now to expand StarMist evolution moveset data, we simply look for free space in this ROM bank. And like I said in the previous part, every ROM bank has free space in them. So this one should have 2, and the ROM bank ends at 43 FFF. So let's go somewhere close to that address, and here we can find some free space. And usually it's better not to leave too much free space before your own data, because, well, you may run out of space if you do. Like here, we don't have that much free space to work with, and because the free space most likely starts at well, if not here, then at this address. Let's just put our new evolution and moveset data here, so that, well, that way we won't make any mistake and rewrite any data that actually is used in the game. So here we have 43E59, and next we need to have the pointer to this ROM address. And just like before, we subtract 40,000 of this and get 3E59. Now we add 4,000 to this, I get 7E59, and form 2 bytes out of it, and rotate the bytes around to get the pointer, which is 59 and 7E. And that is the pointer to this ROM address. And if you check out here, our address is 43E59, and the pointer to it is 59 7E. So you can see the resemblance. The 59 is here, so those last 2 digits are simply used to form the first byte of the pointer, and the next byte of the pointer are formed out of these 2 by simply adding 40 to 3E. If you add 40 to 3E, you get 7E. Put it here, 59, put it here. And this is what this calculation actually does. So if you use 59 7E as our pointer for StarMe, we can move its data here. And the pointer is at 428 AD. Let's go to that address. Yeah, and input 59 7E here. And now if we save it now, we have already repointed StarMe's evolution moveset data to blank ROM space. But next, let's go to address 433DC, where we had the original data. Because it might be useful to write down what we had there originally before writing a new data. So original data, that is 0001 21 01 E5 01 69 01 30 3D 29 25 60 00. So no more evolutions. Learns 21 at level 1, learns E5 at level 1, 69 at level 1, 3D at level 1, and 60 at level 25, which is 37 decimal. You can actually see it here in this unsigned value. And this 00 ends StarMe's moveset learning data. So go to offset 43E59, where we relocated StarMe's data, and write it here. So first we have 00, then we have 01, 21, 01, E5, 01, 69, 01, 3D, 25, 60. And if we now want to make it so, StarMe, for example, learns one additional move, and not just those. Well, if we, for instance, want to make StarMe learn Hydro Pump, which it doesn't right now, because it never learns move 38. So let's just, for example, put 3738 here, which is used for making Starmie learn Hydro Pump at level 55. And if we save it, there we go. By doing all this, we have successfully made it so Starmie learns that new move. Starmie learns that new move, Hydro Pump, at level 55, keeping the original data this actually the same. And if we wanted to do some fine tuning, we'd go to the original address, which was 433DC, and because none of this data is used anymore, we probably want to write some byte for us to remember ourselves that unused data starts here. So I, for instance, do myself it like this sometimes. For instance, we have FF as a marker for us to know that there's unused data here, and FF for telling that the unused data ends here. This is where Starmie's data originally was. Now it is not there anymore. We have free space in the middle of the ROM bank, so we mark it that we have the free space there. So there we go. And I'm back again with after another break, and I was actually planning to tell you something about read access memory or RAM memory today, but that will have to wait for the next part because this one turned out quite long, and I've still got more stuff to be talked about. So basically, what I felt like doing would be talking to you about things called pointer tables. So to start with this, I'm actually not going to tell you that much, except for first locating the pointer to Bulbasaur's data. And Bulbasaur's data was type evolves at level 10 into Ivysaur and 0, 0. And it is right here for 29B3. And again, if you want to look for the pointer to this address, we minus 4000 from it and add 4000 to this. And finally form 2 bytes out of it and rotate them. And this is what Bulbasaur's pointer is. So let's just look for that. B369, and it's right here. And well, yeah, this is where Bulbasaur's pointer is located. And if you check the following bytes after it, you can see this 69 repeating twice after it, and we have CE after. We have first we have B369, then we have CE69, ED69, and so on. And B369 leads into 429B3, which is here. Here we have Bulbasaur's data. And CE69 leads into 429CE. Like I said before, the first byte determines the two last digits of the offset. So the next 2 bytes in the list lead here. And this is where we have Ivy source evolution moveset learning data, as you can see. The next bytes are ED69, so they lead to 429 ED, which is right here. 429 ED. Next we have OB6A, and that leads to 420 42A OB, which is right here. And here we have Charmander's data. Next there is 24.6a leading to this address. No, this one, where we have Charmeleon's data. Evolves at level 36 into Charizard, and so on. And this thing here, we call these pointer tables because, well, they're byte tables where we have byte stored in a certain method, and here we have bytes stored so that, or in a pointer table, we have well, pointer table is formed of pointers, so we have 2 byte pointers to different datas here. And this thing is a pointer table. And there can be lots of other types of tables as well. But yeah. I don't think I have that much to be talked about of this one. But you can actually pretty easily calculate with mathematics for where in this case where the evolution moveset data of a certain Pokemon is located. So, as an example, if I wanted to know where Totodile's evolution data is located, I would have to use a calculator to find it. But as you can see, these 2 bytes here, they are for Bulbasaur's evolution and moveset learning data. The next 2 bytes are for Ivysaur, and the following 2 bytes for Venusaur, Charmander, Charmeleon, Charizard, and so on. And, well, for each Pokemon we have 2 bytes for its pointer in the list, and the first pointer is at 427 BD. The next pointer is at 2 bytes ahead. Third pointer is at so we have, for instance, 10th pointer at 427 BD plus 10 minus 1 times T-Rex2, because this is the same thing as 3 minus 1 times that, and this is 2 minus 1 times that, and this is plus 1 minus 1 times 0x2. Because this here is 0, so first pointer is this offset. So you can find a mathematical way of calculating the location of the water pointer. And for totodile there, we have 9eth pointer, and this is at 427 BD plus 9e minus 1, which is 9d, and that times 0x2. So 9d times 2, and we add that to 427 BD. And get 428 F7. And if we go to that offset, which is right here as you can see, we find FA76 there. And those lead to offset. Well, actually, I didn't think I described this earlier. But, well, to find the address of the pointer, you actually do the same thing in the other direction. So FA76 into 76 FA. You convert this into this address, minus 4000 from it, and add this to the start of the ROM bank. And our ROM bank starts at 40,000. And normally, because we are in this address, you just check where the ROM bank starts like this by dividing the address where the pointer is by 4000 and multiplying it by 4000 again. That's 40,000. So we add 40,000 to 36 FA and get 0x436 FA. So this is how we can find, for instance, totodile's data in the list. 436 FA. I don't know why that didn't work, but yeah. Here we go. We can see the totodile evolves at level 18 into 9F, which is Croconav. Here. Well, yeah. I think this concludes everything for the day. And I was thinking about explaining ROM today, but I'll leave that till the next time and talk more about ROM maps and probably event structures then too. So see you guys next time.